Hello, welcome to this lesson. In this lesson, we are going to look at hydrogenation of benzene. Remember in the previous lesson, we said that we have a number of other reactions of benzene apart from electrophilic substitution reactions, and amongst them we add hydrogenation. So now we want to look at hydrogenation in details. Hydrogenation is simply addition of hydrogen to benzene, okay? Addition of hydrogen atoms to a benzene ring. And when we add hydrogen atoms to a benzene ring, we form cyclohexane. So it takes the benzene ring, which is unsaturated, to cyclohexane, which is unsaturated. And what is the reactant? In this case, the reactant is hydrogen gas. And the condition for the reaction is nickel catalyst at the temperature of 200 degrees Celsius. Okay? So whenever you are doing hydrogenation, the reactant should be hydrogen, and the conditions nickel catalyst at 200 degrees Celsius. An example, you have benzene reacting with 3 molecules of hydrogen, which is the same as 6 atoms of hydrogen, to form cyclohexane, but in presence of nickel catalyst and at 200 degrees Celsius. Now, something to note, which is seemingly obvious, is that sometimes when you are writing nickel as a symbol of nickel, you forget to put the dot on the I. That is very important. Okay? So it is nickel is capital N, lowercase I. Okay? Good. Okay. So this reaction is very important in organic synthesis. How is it important? We use this reaction to remove the delocalized pi electron ring in the benzene ring. Okay? So that double bond containing pi delocalized electrons can be removed by hydrogenation. Okay? So it helps us to convert the unsaturated benzene ring to a saturated cyclic compound. Okay? And therefore, whenever you have a synthesis number that requires you to remove that ring inside the benzene ring, then just know you have to hydrogenate that compound to remove the unsaturated bonds there. For example, when you have phenol and you want to convert it to cyclohexanol, you realize that the only difference is in the ring there. See that there is a ring in phenol. Inside the benzene ring, there is that pi delocalized ring of electrons. But in cyclohexanol, that ring is not there. So to convert, you simply have to react that phenol with 3 molecules of hydrogen in presence of nickel catalyst at 200 degrees Celsius, and that removes the ring inside there. Okay? So we have there some synthesis numbers that you can practice. One is converting converting nitrobenzene to cyclohexanol, or forming cyclohexanol from nitrobenzene. Now, I want you to notice, whenever you want to know whether you have to apply hydrogenation, just look at the two sides. The reagent side, if it has a ring and the product side doesn't have a ring, but it is still cyclic, then you know that actually you are supposed to remove that ring inside the cyclic compound. Okay? So, here we go. We have, in nitrobenzene, we have a nitro group attached to the benzene ring. Then in cyclohexanol, we realize that we have a OH group instead of a nitro group. And the other difference is there is no more ring inside that cyclic compound. So we have two things to do. One, to convert the nitro group to OH. Then two, to convert the benzene ring to a saturated cyclic compound. Okay? But we know the solution to one. We know that to remove that ring inside the benzene ring, we simply have to hydrogenate. So that is sorted. But how do we convert the nitro group to OH group? That is what we should tackle first. Okay? So to convert the nitro group to OH group in a benzene ring, you just need to convert that nitrobenzene to phenol. How do you convert it to phenol? First, reduce the nitrobenzene using tin in concentrated hydrochloric acid and sodium hydroxide solution. When you heat, you will form amino benzene. Then react the amino benzene with sodium nitrite in presence of concentrated hydrochloric acid at ice cold conditions at that temperature, and then you will form benzene diazonium salt, specifically benzene diazonium chloride. Then benzene diazonium chloride can now be converted to phenol. How? React it with acidified water and you heat. You will form phenol. Now once you have formed phenol, then our job is done. Just hydrogenate now the phenol, because you now need to only remove that ring. So just hydrogenate the phenol to form your cyclohexanol. How? Add 3 molecules of hydrogen in presence of nickel catalyst at 200 degrees Celsius. And there you are done. Okay? A second example. You are forming cyclohexene from iodobenzene. Iodobenzene has an iodine atom attached to a benzene ring. But cyclohexene is a cyclic alkene, cyclic alkene with one double bond. So you realize that actually we still need to remove this ring. Then two, we need to convert now that after removing the ring, we shall form an alkyl halide, cyclic alkyl halide. Now after that, to convert the cyclic alkyl halide to an alkene, then you need to dehydrohalogenate it. So let's do it. We have, first of all, remove the benzene ring. How? React it with hydrogen in presence of nickel catalyst at 200 degrees Celsius. We shall form a cyclic alkyl halide, which is called iodocyclohexene. Then to convert the iodocyclohexane to cyclohexene, you simply need to dehydrohalogenate. What are the reagents? Sodium hydroxide solution or potassium hydroxide solution in presence of excess ethanol, and we heat. Then we shall form the cyclohexene. Okay? Another example, example 3. We want to form phenyl ethanol. We want to convert phenyl ethanol to cyclohexyl ethanol. Something to note is that the